Hi, everybody. If you go to my agenda, what you're going to do, you're going to, on my agenda, I have not posted it yet, but right about here, you got to go here on today's date, the 20th, and you'll have a link. I'll post it in a few minutes, but you'll have a link and you'll make a copy of those notes and save them to your sixth grade science folder. So please do that. It'll be this slideshow density of regular shaped objects, and that'll make more sense in a little bit, okay? But what we're gonna do first is honestly talk about mass first, okay? And then we'll start to maybe move into these notes, maybe. So, we're gonna move into mass. So, when we talk about mass, um, let me open up the little worksheet thing that I had. Where is that thing? Let's see, right here. So when we talk about mass, I'm going to use the little pen, and mass is different from weight. Okay? So mass does not equal weight. This is what I want y'all to understand. When we talk about mass, we're talking about how much matter is in an object, meaning how much stuff makes up you, me, a coffee pot, TV, whatever, okay? Weight has to do with gravity. So when we talk about weight, we mean gravity, okay? For example, if you were able to travel from here to the moon, your weight will change from place to place because there's different gravity on the different planets, all right? There's so much less gravity on the moon. So therefore, you're going to weigh less. When you're on Earth, you're going to weigh more because gravity is pulling you down. All right. Your mass, however, if you travel from here or the moon, the mass will not change. Mass is how much matter makes up something. Okay, how much matters within a given object. Meaning it doesn't change. So you're not going to shrivel up into nothing when you get to the moon. You're just going to be the same you. Okay, so please remember that mass and weight are totally different, okay? I'm going to pause really quick and then I'll be right back. All right. So now that you know what mass is, scientists use this thing. It's that triple beam balance. If you've ever seen it, nowadays we can use a digital one that's real easy. You put the object on, it gives you a reading. But we need to know how to read it off an actual triple beam balance, the one with all the different riders, the different lines. And yeah, so we need to know how to do that. When you put an object on a triple beam balance, it kind of goes clunk to one side. So, like a seesaw, you want to balance it out so both sides are kind of floating. So, in order to do that, you have to move these riders. Okay. So, usually you'll start with the biggest one, all right, and kind of go from there. Um, don't pay attention to that. I'm going to switch to green for this example. So, you can see that if you were doing an experiment, you'd have all the riders at 0, then you'd start with the biggest one and start moving them over to where it would balance out with the side that has the object on it. But in order to read a triple beam balance, we're going to read it off what the numbers that are given and get an answer, okay? And you will see this in the Canvas assignment that you'll complete after the video. So to do this, you have to read each line. Again, start with the biggest one and I'd write them off to the side. So you can see that this is at 100. So you can do it in your head, but remember you can use a calculator in science. So if that's 100, then this one's at 90. And then this one's at, now the bottom one I always tell kids, you have to read it kind of like a ruler. You see that the lines aren't quite at 1 yet. Like this is 1, this is 2, and this is 3. The lines are not quite at 1, so you have to count each one individually. Like this is 0, 0.0, 0, 0.1, 0, 0.2, 0, 0.3. It looks like it's almost like 0, 0.4-ish. So you'd put like 0, 0.4. You can type all that into a calculator if you can't do it in your head, and you add it all up, you will get 190.4 And it's not just 190.4. I'm telling you guys right now that in science, the subscript or the method or the unit of measurement, I should say, not subscript, unit of measurement, in science, it's super important. So for this, for any time you do math in sixth grade, it's always going to be in grams. Okay. So you have to have a G at the end of math. You always know if a problem too later on is giving you math, even if it doesn't say it. If it says like in the problem 20 grams, you know they gave you the math. So just remember that. Okay. So I'm going to kind of clear out of that and move down. We're doing the same thing in all these problems. You're just adding up the riders, okay? So you're going to see a couple more of these problems in a Canvas assignment you will see. So remember, just addition for those parts, okay? Addition. Now, scrolling down, because I'm going to skip all this, um, you are going to eventually run into problems where it's volume by water displacement. We are not there yet. We're only going to focus on mass. And then, like I said, we're going to go ahead and jump to your interactive notebook. So you should open that up at this point. And we're going to move to the slides. Oops. I guess I need to get out of the whole pen thing, right? So there we go. So on this slide, the first one, if you were quizzed today, which questions would you already know the answers to already? So you need to answer this first question in this set, and then the second question here. Remember to pause the video and type it in. So how do you calculate the density of regularly shaped objects? If you know, type it in. If you don't, put I do not know. How can calculating density determine the identity of an unknown substance? I think there's a little bit of a typo there. But if you think you know the answer, type it in. If you don't, then leave it as is. Okay? Because, I mean, not leave it as is, but like type in, I don't know. Okay? A lot of you will probably put I don't know for these, but you do need to fill them in. If you have any idea, go ahead and write it in. So we will move into volume. So just remember for now, when we talk about volume, volume is how much space an object takes up. Mass is how much matters in an object. Remember, that doesn't change no matter where you go. And volume is how much space something takes up. Remember, we talked about the example with like you getting into a filled up bathtub and you displace the water, like the water comes out of the tub if it's filled up too high because you take up space. All right. When we talk about density, density is going to be a ratio of an object's mass to its volume, like how much mass is in a given volume. So basically, we can determine if objects sink or float by calculating its density. All right. The reason we can do that is because, and I'll switch to purple. For water, just giving you an idea, guys, water has a density of 1 gram per milliliter. If when you calculate density later on, if anything's less than 1, it's going to float. If anything's greater than 1, like even 1.1, it'll sink. So without even doing an experiment, we can calculate if things float or sink just by calculating an object's density. Okay? So I'm going to get out of the pen, at least for now. This is honestly something you should memorize, and you see like there's a heart, okay? So this is the I heart density formula. Whoops, I kind of messed up with the pen there. But this is the I heart density formula, meaning mass divided by volume. So the formula for density, and you should honestly like memorize this. Even though everything's open note, you should memorize it. The formula for density is mass divided by volume. I know in math class you could have like the little division sign and you have to do all this and stuff, but you don't have to do that in science. Remember, you can type in a calculator mass divided by volume. So you could type in the object's mass, then just push the division sign and then type in the object's volume. Okay? So mass over volume, mass divided by volume. So if you write a heart around it, you know which one goes on top and what one goes on the bottom because the top of the heart looks like an M. The bottom of the heart looks like a V. All right? So again, for density, it's mass divided by volume. And for us, the answers are usually in grams per cm3. The grams represents your mass. The cm3 represents your volume of a regular object, like a rectangle or a square. So if you just remember that, you'll be great, okay? So again, I'm going to clear out of that and get out clear. I'm not out of the pen yet, so we'll see. I'm kind of new at this stuff, so we'll see. But anyways, moving into the next screen. You can see here that density of regular objects. Well, I even told you here, 1 centimeter is like pretty much equal to 1 milliliter. So just let you know, guys, again, volume is the amount of space taken up by quantity of matter. So volume is how much space something takes up. Okay. To calculate volume of an object, such as a square, a rectangle, something with four sides, right? That is kind of that perfect kind of square, a cube, whatever. Um, when it's something like that, we can calculate it length times width times height. All right. So moving into this slide, and you need to answer the question on this one prior. I'm sorry. What does volume measure? Well, it's going to measure the amount of space something takes up, right? So you need to type that in there. All right. When you're ready, then stop the video and then you can continue. Okay. So when we calculate volume, if you're given a length, a width, and a height of a rectangle or square or something, even if it doesn't ask you, you know if you're given a length, a width, and a height, you need to multiply them together, like this formula here, and you need to calculate density, or you need to calculate volume, I'm sorry. So if you're given L times W times H, length, width, and height, you need to multiply them together and you'll get a volume. Usually your answer will be in cm with a 3. Because usually in 6th grade, at least, we always do, and even 8th grade for the most part, you'll always do centimeters. And the reason we put a 3 behind it is because, look, you're calculating 3 things together, multiplied. So it's a 3 as like a subscript behind the unit of measurement. Okay? So just letting you know, moving into the next screen, it says calculate the volume of a rectangular prism. Show your work below. Be sure to include the formula you used and unit labels. Well, you're just going to do your best because it's hard to draw and everything on here. But if you can at least like type it in and say like I divide or I multiply or whatever. But we're going to do this together, so you should be able to type it in. So first, oops, sometimes when you go to type, you have to delete all this stuff. So first, I'm going to say volume equals length times width times height. If I know that, then number 2 step, I can say the length 6 times 5 times 20. You'll get an answer, and then you put your answer here. Okay, now your answer, reminder, if you go on a calculator and multiply it out, like on my calculator, if I were to do that, and I do 6 times 5 equals times 20 equals 600. For step 3, I can put 600 and the answer needs to be cm, and I can't do it on here, but you should just know that it's like cm3 with the 3 kind of above the m, okay, like a subscript, just above, not below. Alrighty, so that's that. Yeah, so when you're ready, then move on to the next slide, but remember you need to always have cm3 and you're multiplying all 3 sides together. Okay, so when we move into mass, again, we already went over. It's the amount of matter in an object. So it's measured with a triple beam balance or a scale, like the digital one. Okay, so what is mass type in this definition up here. When you're done, we can move on. Remember, in 6th grade, we always use grams, okay? So type it in, and then you'll move on. So this page says, think about it. Why do scientists use mass instead of weight when calculating density? So think about it, then write your answer in here. Why do they use mass instead of weight? Well, guys, again, you got to remember weight has to do with gravity. And when we're using mass, we're just looking at how much matters in an object, and that's going to stay consistent. So when we calculate density, we just need to know how much matters in an object within a given volume, pretty much, so we can figure out why some things sink and float. All right. So let's like kind of summarize what I said in this answer here. If you need to re-listen to it, just rewind and re-listen. Okay. Then we'll move on to the slide. So try this density problem. The rectangular prism has a mass of 600 grams. So again, if I go to type in here, sometimes you have to click multiple times, and if you have to add a text box too, it's fine. So if I have, remember, mass divided by volume. When I type it in, it looks weird, but mass is on top, volume is on the bottom. Okay, so even if you were to write it in, but find the density. So the formula for density is mass divided by volume. So they say it has a mass of 600 grams. So 600 grams, okay? Now I'm going to divide that by what? Well, obviously for volume, we need to find it. And it's length times width times height. So if you forget, like which one you should do first, like you see that, so go back up here. On this page, it says, oops, so the length one is this one. We got to do that first, times width times height, okay? So back down here, so it's going to be 5 times 10 times 6, okay? So your answer, when I use a calculator, it's going to be 5 times 10 equals 50 times 6 equals 300. So my volume is 300. I can now plug that into the volume in the formula. Okay, so 300 meters in this problem. Okay, most of the time we use centimeters, but in this one it's meters. So it's meters with the 3. Okay. Don't forget, if I use the pen, it would probably look more like this with the 3 up higher. Alrighty? But anyways, if I type this into a calculator now, and I need to guess click back on there. If I type this into a calculator now, I can pull the calculator back out, and I'm going to clear this out, and I do 600 divided by 300, and it equals 2. So the density is 2, but remember, for density, we need mass and volume together. So it's going to be grams per meters 3, per cubic meters, not meters 3, but it's actually pronounced cubic meters, okay? So you actually need all that for your density. And obviously this object is greater than 1, so it's going to sink, all right? Whatever this mystery object is, it's going to sink. So kind of going into the next slide, you can see density of regular objects. So what is the density of the cube? You just need to type the answers in. So if you kind of read through here, it tells you a real world problem. A golden colored cube is handed to you. The person wants you to buy it for $100, saying that is a gold nugget. You measure the cube and find that it has 2 centimeters on each side and has the mass of 4 grams. So in this problem, it's asking you first of all, what is the volume of the cube? Since it's a perfect square, it's going to be 2 on each side. So you don't even need to write anything down. You just need to multiply 2 3 times. But it's not 2 times 3. It's 2 times 2, and we know that's 4, times 2 again, equals 8. So your answer here, if you go and type it in, will be 8 cm3, okay? So it's asking for the density of the cube. Well, it's not on this chart, so you can't just jump here and go and, find it on here. You actually need to go and calculate the density of the cube. Okay. So I know that density, if I write it with my pen, density is mass over volume, mass divided by volume. So I can go ahead and type into a calculator, or I could write it out if it helps. But the mass they said was 40 grams. So I can type in 40 divided by 2 times each side. We already found out the volume's 8. So I can divide it by 8. And it equals 5. All right. So I can type in 5. Now the guy is saying it's like uh, a gold nugget, but we just found out the density is 5. So we should write 5 in here. Okay. 5 grams per cm3. Now, is it gold? Well, if you look at the chart and you look at gold, gold says 19. So is it gold? No. Should you buy it? No. Okay. So just letting you know that that's how you would find that problem. Alrighty. So hopefully you followed along with that. Moving into this slide. How do you calculate density of a regular shaped object? So again, the formula for density, make sure you type it in, is mass divided by, come on, is mass divided by, let me delete that, mass divided by volume, okay? Now this is just letting you know, put mass on the top of the heart because the heart looks like an M, put volume on the bottom because it looks like a V. So solve the equation. How do you calculate density of a regular shaped object? Complete the sentences by typing your answers. So again, solve the equation. It's mass divided by volume. All right, don't forget mass divided by volume. If the density is above 1, it sinks. If the density is below 1, it floats. Okay, so moving on. Density of regular objects. Density of a material remains the same regardless of how much of the material is present. So we have a few more slides to get through and then this video will be done. All right, so on this page, you have to calculate the volume of the rectangular prism, calculate the volume of the cube. So the volume of the rectangular prism and the volume of the cube, and then calculate the density of each. All right. All right, so for this, they gave us everything we need. So I'm going to write with the pen, but y'all can like type it in to show your work. So just to kind of show you, we need to find the density of both of these. But obviously they only gave us mass and we need to find the volume. So for the prism here, we obviously need to find a volume and we need to do length times width times height, right? Okay. And it tells you at the bottom here that each ball represents 1 centimeter. So the length, we're going to count these. Okay, so 1, 2, 3, 4, 5, 6, 7. So 7 times, oh, actually I messed up because we don't need to count the last one because it's going up. We don't need to count the first one because it's going up. So actually it's 6. So if you go back and count the middle, 1, 2, 3, 4, 5, 6, 6. Then the width, 1, 2, and then the height, 1, 2, 3, 4. All right. These are actually harder problems, so I wouldn't worry too much about these guys. Just kind of understand that you have to calculate density. So if I, on a calculator, go 6 times 2 times 4 equals 48. That's the answer. So you can like type this in here, but the answer I get is 4. Okay, so now I know that's 4 cm3. And the density, I can go ahead and know that the mass is 10. then the volume is 4, and I can type in 10 divided by 4, and I get an answer of, and you saw it was on the calculator, 2.55. And remember, you need to have mass and then volume in there, okay? Right, so you do the same thing over here, but just remember, guys, the cube, you don't even need to count this. You only need to count one of them. So if I'm comfortable with like height, I know it's always the one that's going up. 1, 2, 3, 4. There's going to be 4 on every side because it's a perfect cube. So all I have to do is do 4 times 4 times 4. So 4 times 4 times 4, because length, width, and height are all the same. So my volume is going to be 64 cubic centimeters. And I should have, in all honesty, put centimeters in that last answer. For those of you who are like, wait, why did you switch to meters? I messed up. It's centimeters, so put CM3. Okay. But if I go to the pen, it's 64 is my volume, CM3. Okay. And again, that should have been a C. But density, again, is my mass. In this problem, it's 5 divided by 64. Okay. And if I go to the calculator, 5 divided by 64 equals, and we don't need to move decimals or anything, but in science we typically round to past the decimal, and if it's a multiple choice answer, you like pick the closest one to what your answer is. So to pass the decimal, I'm looking at the 7, but in order to determine if the 7 stays a 7 or rounds up, I look at the 8. That is 8 or greater, that is 5 or greater, so this 7 becomes an 8. So my answer then goes to 0.08. All right, so the answer now is 0.08. I'm sorry if you didn't see that point 0.08, and it's grams per cm 3. Okay, so get that typed in. How does the density compare? Well, for the cube, you could even say this object is going to sink, this one's going to float. I mean, that's what I would say. But I mean, obviously the rectangular prism is more than the cube, and you could type that in there. Okay, so pause, get that all done, and then you can continue. Alrighty. Moving on to the next one, quick action. Again, this is going to be a longer video just because it is all about density. You're really doing your notes and filling it in, okay? So that's kind of what we're doing today. You'll do an assignment late, like the next day, but right now it's just doing your notes and getting it filled in, all right? That is what today is all about. So looking at this, a block of lead has dimensions of 4.5 times 5.2 times 6.0 centimeters. The block has a mass of this. Find the density. So that's what we need to do first. I'm not worried about anything else. I just need to find the density. Okay. So in order to show your work, obviously you're going to type in, and I would say we need to find the volume. So volume equals length times width times width times height. All right. So and that might be confusing you if it says like 2. So that's the first thing. So volume equals, and we're just gonna on a calculator type all that in. So on a calculator, we need to just type in 4.5 times 5.2 times 6.0. All right, and you get for this a 140.4. So that's going to be your volume is 140.4 cm3 for cubic centimeters. Okay, so that's not it. It asks you for to find the density. So your first step is finding the volume. Then the density would be over here. Let's go ahead and type in density equals mass divided by volume. So I know the mass is 1587 grams divided by, and I know I've got the volume just now of 140.4. So if I go on my calculator again, because those are weird numbers, I want to use my calculator. 1587 divided by 140.4. And the answer here is, let's go back to the calculator, 11.30, but we really don't need that zero. So you could just write 11.3, but we also need grams per cm3. Okay, so that is your density. Explain how you found your answer. Well, I mean, if you actually typed it in good, then you could literally say, we could literally see my work I showed. Okay, like how to find the answer. Like we divided mass and volume. Okay, so that's pretty much it. Looking at the next slide, density of regular objects. If you look at this, you have ice, warm water, cold water. Okay, which one has the greatest density? Well, which one's sinking the most? Cold water. Which one is least dense? Which one's floating? Ice. Okay, so temperature affects density. So when heated, molecules move faster and slightly apart. You can see when it's heated, they move faster and slightly apart. Mass stays the same, volume gets larger. All right, results in a decreased density. So you can see as the heat sinks, cold water, but then the volume gets larger in ice, so it's going to float. All right. Think about it. 3 different liquids, X, Y, and Z, are going into the same container. There are 15 milliliters of each liquid. All right, 15 milliliters of each liquid. X has a mass of 30 grams, Y has a mass of 52.5, and Z has a mass of 11.25 grams. Calculate density data for the liquids to predict how the 3 liquids will separate into layers. Alrighty, so we're going to put our answers for the density there. Alright, so looking at this page, it's going to be really easy because it's asking you pretty much to tell you the density of the 3 liquids, and it's telling you there's 15 milliliters of each liquid. So this is going to be the volume, and then literally these are the masses of each object. So here we go. So in all honesty, this first one, and I really don't know how I made the pen thicker, but let's switch the color to like blue or something. So for X, we'll do X in blue. Remember for density, it's mass over volume. Okay, so the mass is 30. The volume is 15. So let's go and use the calculator. 30 divided by 15 equals 2. So when you go and type in your answer, this will be 2 grams per milliliter. Sorry, my writing isn't great on here. So let's switch then to purple. The one for purple is Y, and I already told us it's 15, so I already know the volume for this one. Then the mass is 52.5. Okay. So we have 52.5 divided by 15. So 52.5 divided by 15 equals 3.5. So when you write your answer in here, and my answers are probably going to be weird, but 3, like, kind of messed up with the writing, grams per milliliter. And the last one we'll do in like red. So again, it's going to be the same volume. And then it's 11.25 for mass. So on here, 11.25 divided by 15, 0.75. So you can type in 0.75 grams per milliliter. It says explain why this would happen. So it says calculate a density for the liquids to predict how the three liquids will separate into layers. Well, you can kind of see that each one's density, like this one, will be on top. This one will be in the middle, and then this one will be on the bottom, okay? Because it has like the least to greatest with the density of floating on top of each other. So I mean, like in this answer here, you could type in that the layer Z is the least dense, so it'll float. Layer X is like the middle between them all, so it'll be like in the middle layer, and Y will be the low bottom layer because it's the most dense, like it'll sink the most. Okay, so we're gonna go ahead and move on to this next page. All right, so for this page, you're going to do it by yourself. So it's giving you a mass and a volume. Find the density, put it right here. Now you have a mass, then you have to multiply these three together and get your volume. So then you'll divide this by whatever your answer is for this, and you'll get a density. Then same thing, same process, and you'll get a density. Once you actually have each of the three densities, like the previous page, you'll need to click and move these to the right spot that you think they go in. Alrighty. And once you have them in the right spot, then you can, kind of show how they'll float and sink and which one's on top of each other on here. Okay. So you'll do that. When you're done with that, then you'll check for your understanding, explain how to calculate the density of regular shaped objects. Really, the formula, like, okay, mass divided by volume. And then you need to find a volume, like length times width times height. Explain how you can use density to identify an object. Well, you can figure out if that object sinks or float. So you need to write that in there. Then the next page, what essential questions do you still need help to understand? Well, just tell me if you have any questions so far, okay? When you're done with all that, make sure up in the corner, because it will say copy of, delete where it says copy of. Make sure you save this to your sixth grade science folder. So you click back and click in the sixth grade science folder, so move it. And then tomorrow, or you can do it when you're done, you'll put it in Canvas and it says like note submission area. So you'll put it in the note submission. Yeah. So, that's it. Let me know if you need me.